All right, dude, we are live. What's up, guys? This is Dem Keys, and today we are going to be taking a look at, we're going to continue working on the content pipeline, but specifically, we're going to be taking a look at the concept of sliding windows. Basically, imagine you have an array of values and you only want to read a certain set of the values, a certain contiguous set, a contiguous sequence, right? So you want like small windows of these views, but you want to have like a sliding window sort of effect. So you want to read, let's say you have array values 0 to 9. So that's a total of 10 values. You want to read a window, you want to read using a window of size 3. So it's going to read 3 elements at a time. So you read 0, 1, 2. That's one window. Then you slide the window by one element, and then you read 1, 2, 3, slide again, 2, 3, 4, slide again, 3, 4, 5, and so on until you hit the end. Now, I could try and implement this manually, and I've tried to do something like that in the past, but I did notice that there was a bit of reinventing the wheel going on. And I mean, I've done it in the past. I don't want to have to do it each time that I want to implement, each time that I want to use a sliding window. I don't want to have to implement it over and over again. So, um, so I was looking for ways to do it through some of the libraries that I might already be using, and NumPy happens to be one of those libraries. And fortunately, it does also have a sliding window thing. NumPy is arrays is actually what NumPy does really well. Storage of arrays, arrays being handled in memory, calculations between arrays, and much more. NumPy is known to give you functionality to deal with these arrays, not only in a high level way, but also in a highly optimized way. So in a way that you can deal with massive arrays of data and still be able to do calculations between them, and also still be able to operate on them. Where was I going with this? I kind of got distracted with talking about the features of NumPy. Sliding window. So NumPy just so happens to have a sliding window function for ND arrays, and that's what I've been playing around with, and that's also what we're going to be looking further into in this stream. So so far, what I've got here, actually another one is pandas. Pandas also has a similar function, a similar sliding windows function or sliding window function. The function itself is called rolling. So at a later time, I'm going to be looking into that as well. But right now, it just so happens that our list that is returned, or our transcript that is returned, because that's what I'm trying to do the sliding window thing over. Our transcript that is returned, it is a list of dictionaries. So all I have to do is pass that list into an ND array. So we then have that in the form of an ND array, and then I can run sliding windows over it. Or I can run a sliding window over it. I think that's a more accurate way to say it. I can get rid of this now. Hold on. I think I can get rid of this as well. Hold on just a second. There's something I need to do. Also, unfortunately, I still haven't managed to get Ubuntu on WSL to start up. Man, I'm really considering starting using this laptop as a PXE boot device rather than what do you call it? Rather than trying to use it in its current state, because the hard drive on this device is also on this laptop is also actually I'm saying also in relation to another laptop that I was trying to do the PXE boot thing with. Now instead, I think I'll try and do it with this laptop. And this laptop, it's got pretty decent hardware. If only I was able to use the hardware, um, I would be able to do so much with it. But yeah, dude. Yeah, at some point, I'm gonna look into setting up the PXE boot thing, at least to start up the device. Because like, I don't think I need to install anything. Because the whole idea with, at least with my specific PXE boot scenario, is that I don't want to. What was I saying? Oh yeah, I don't want to install anything on the hard drive. I don't want to use the hard drive at all. I want to use this laptop's resources without using the hard drive, without touching the hard drive at all. So even the loading of the OS, um, or even the running of the OS, it's all going to happen from whatever is within the memory, and any hard drive related stuff, it's going to be done over the network. So one of my other machines, hard drive space is going to be used in order to store things that this PXE boot machine needs. There is a bit of a setup that I have to do before that. So I need to look into how I want to go about doing that. I also noticed today on when I was looking at BTOP, here, give me a second. I can just, yeah. I also noticed here the root partition, it has 170, it has 107 GB free. In total, it's got 183 GB of space. By the way, you guys, there are certain colors that you can't see, more specifically green colors that you can't see very well because it's being green screened out, but this is sort of what my BTOP looks like. Yeah, today I noticed there's like 107 GB free, and if you look at my home partition, there's only 22 GB free, and there's like a bunch being used up. Quite often it's the VODs that take up a lot of space, but there's also caches from other programs, temporary files from other programs. Every now and then I have to go through this and like get rid of stuff that's not required. Um, so I want to see if there's a way that I can move some of the free space. That would the problem is that would require like repartitioning the hard drive space. So I would have to, I don't know, deallocate hard drive space from yeah, hard drive space from the root partition and reallocate it to the home partition. And I'm not entirely comfortable with doing this because first of all, I've never done it before, so I'm not too sure about what's gonna happen there, and if there is a chance of data getting corrupted. um, I forgot what the second thing was. I said, first of all, I'm not comfortable with this. Um, yeah, I don't remember what I was saying. But yeah, I need to go through I need to go through a cleanup process again and try to free up memory here. I do have another machine on which, let me see how much space is there on that hard drive. So we are looking at the root. By the way, I when I saw like 100 and something GB for the root partition, I was like, why did I do that? And then I noticed that 76 GB was being used up, and then I was like, okay, probably a good thing that I did that. because it's not Ubuntu itself that's that heavy. Ubuntu itself would be pretty small, but then there's a bunch of other applications that I'm using, and there's a bunch of stuff. For example, Snap. When you install Snap, it apparently it holds on to like previous versions as well, of certain programs, and also, based on what Gemini is telling me, if you have upgraded, because like in on this machine, I've upgraded from Ubuntu. I believe I've upgraded from Ubuntu 20 to 22, and then from 22 to 24. The 24 upgrade was, I think, a year ago, maybe, that I'd done it. I don't remember. Maybe it was a year ago. Give me a second. Let me open up my stream on my phone so I can see the chat. Okay, so uh, yeah, so apparently it holds on to some of the runtimes from the older versions, just in case you have programs that were installed in the older versions and were never they were never updated. So then it'll be able to run those programs. I'm not entirely sure what the specifics are surrounding that, like what the limitations are there, but that's apparently a thing as well. And those runtimes end up being like 500 MB plus, so that takes up a certain amount of space as well. Anyways, I'm looking at this other machine here, and it is showing me. Give me a second. For home, I've got 800 GB. That is insane. I've got 800 GB for holy shit. Holy shit. I've got 800 GB of space here for the home partition. For boot, which, dude, learn from my mistake. Always set the boot partition to be a couple GBs. Doesn't have to be like 25, 30 GB. It can be less than that, but definitely set it in the GBs, because I looked at really old advice where people were like, okay, you can keep the boot partition small. It's not a very big deal. But then over time, if Ubuntu or whatever your OS, whatever your distribution is not clearing out the older kernels that were installed, slowly it's going to start to pile up, and then eventually, at some point, your update process is going to start to fail because the boot partition is full and it can't hold a new header, a new Linux kernel that needs to be installed, or it can't hold the files, it can't hold the necessary data for the new thing that's being installed. So the update is going to fail. In my case, it kept on failing until I ran some kind of command that compressed a bunch of this stuff using a certain kind of algorithm, and then it made a bunch of that smaller. So then I think my boot partition had now it has, I think, 445 MB remaining, or maybe that's the total. No, the total is 445, and I think remaining is 220 megabytes. Okay. Yeah, I need to. The thing is, on this machine, I don't know if I should try to put things. I mean, it's tempting, especially, considering 800 GB of free hard drive space just there. Well, oh, hold up. Uh, Wait, I could be wrong about this. I don't know. In total, it's 804 GB. I don't know if what I'm looking at in BTOP is um, the the free space or the used space, because oh, it's saying the used space. Okay, yeah, it does say U there. So it's so far 210 has been used up, and there's a good like 500 to 600 GB remaining, around 600 GB remaining. So if I decide to run the PXE boot thing, I would be better off running it from this machine. But then the problem is that this machine doesn't have the best resources. It only has like 6 GB of RAM, and I would be stretching things pretty thin trying to run the entire thing off of this. I'm better off running it off of the other machine. Anyways, dude, okay, enough about that. Let's continue with the sliding windows thing. So I set up a thing. Hold on, I need to. We don't need C. We also don't need A. We do need B. And then we specify a window shape of 6. So the window is going to hold 6 elements, and that means it's going to slide what we have 1 and then 2, 3, 4, or 5, right? Because if we are holding up to 6, that'll be 0 to 5, and then 6, 7, 8, 9, 5. Yeah, it'll be 5 windows in total. So if I save this and run, then, well, you're already seeing the result here. Okay, now I think I want to read the transcript. So let's say, yeah, let's say trans O1 equals just empty. And then with open, I think I need JSON here as well because I have to deserialize the, is it in JSON? It's not in JSON. Though, wait, no. I did serialize it to, it's in JSON. Yeah, I serialized it to JSON in order to write it to the file. So what I'm looking at is JSON. So let's import JSON, and then with open, dot slash data slash transcript, and we'll take this transcript. And we only want to read. Okay, so as fr, wait, what's going on? There, fr trans o1 equals json.load fr. I don't think there's an indent. I also don't think we need to specify the indent here. I think it just I think it handles that by itself internally, because I haven't had a situation where I had to specify the indent while reading. I only had to specify it while writing because by default there's no indentation. But if you specify indent, then it's going to do the new line and providing indents, to show separation and stuff like that. Right. So trans O1, B and so and so. Oh yeah, here I was trying to create this thing. Okay, yeah, we already have the list here, right? Oh God, what just happened? Okay, so this is already gonna be a list, so we don't need to do any of this. We can just do trans O1. Okay, So D and so. Okay. And then, oh, wait, no, you know what? There's probably a lot in here. So I'm gonna do up to 20. Yeah, I'm gonna do up to 20. So this is our, oh wait, this is printing out, right, hold on. So we don't wanna print out all of this. We just want the first thing in D underscore win. So this is our sliding window. I can change this to, there's an error here. Man, my typing is just going to shit today for some reason. Yeah, so we can change that. Did that change? Oh yeah, it did change. So if you look at the difference between the, hold up. If we want to specify, because I haven't used the step thing a whole lot, so I need to play around with that a little bit. If we how do I want to go about doing this? What if I do this is, so that prints the entire thing. What about here? I think that might throw an error. No, that's not throwing an error. Okay, we are live. It's reading from 0 to 1, and 1 is exclusive. So if it's reading from 0 to 2, it's going to read 0 and 1. Is it? I'm not sure. Yeah, I haven't, wait. When we are using the step thing, I need to learn how to read like the ranges in steps. Hey, so in Python, I know how to do this thing to select a range, but what if I wanna step over values and also index? Because like I know how to step over the values. Like for example, I could do something like this where it's gonna step and show you like every two values. Hold on, what does it show over here? Or wait, let's make the window. The window is 6. There's 20 values. Let's make it 10. And this steps over 2. What is this displaying? I'm looking for square brackets here. Okay, I see it. So we have square brackets here. This is the third one, I believe. Right, and then we have another set here, right above that. So that starts here, and it ends over here. Okay, and then we have another set above that, which is here. So this is already stepping in like in terms of 2, and we can verify that by saying this text is very long, dude. I need to come up with like a simpler simpler example. So let's create a C, and let's do a, this is a sentence. Well, it doesn't have to be, a, yeah, this is a sentence. This is another sentence. This is yet another sentence. And this is yet another sentence. Okay. This is only... Okay, here comes another sentence. We sentencing up in here. Is this a sentence? Fields sentence map. Okay, so we have, what is that? 8 different values. And now here we are going to construct the array out of, well, we can just do this, equals np.array, C. Okay, and now we can turn the window size down to 3. And now we can see what this looks like. So we are looking at a total of what? This steps in twos, right? So there's going to be 3 in total. Okay. So okay, wait. For the sake of being able to read this, I think I need to add some extra texture. So let's say first, I should have done this like from the beginning. Or it doesn't even have to be like, hold on. I don't know what was backup. We need to. Okay, we are good. Yeah, sorry. I need to be careful about what gets left in NeoVim's registers. Okay, so we're going to do 0 and 0, 1. 0, 2, 0, 3, 0, 4, 0, 5, 0, 6, and 0, 7. So that's a total of 8. And now if we run this, we can see our result. Now we can see the window. So we can see 0, 1, and 2, then 0, no, we can see 0, 1, and 2, then 2, 3, and 4, and then 4, 5, and 6. And then it doesn't go to the next window because it's not able to step to, you know, the very last thing. Or rather, it's not able to take 2 steps because that's going to go beyond the size of the array. Okay. Now we are going to go and take a look at the range syntax. Okay, think of it like a set of instructions for a scavenger hunt through your list. Okay, stepping over values. If you want to skip items, if you want to yeah, if you want to skip items, you use the third slot. For example, if you want every second item, the evens or odds, depending on where you start, you set the step to 2. All right, okay. So this is then going to return the entire, okay, so then this is returning an entire, this is returning an ND array as well, I'm assuming. So if we do, wait, let's do it here. Oh, wait, no, let's do it in this way. D when, oh, let's do it here. D when, yeah, whatever. D when step. D when, so and so, so and so, there. And then we do D when step. But before that, we want to do D when step. Right. So it voice crack. Holy shit. Right. So it returns an ND array, and that means if I want to access, if I do index, like let's say, well, I can do the indexing here, right? I could do yeah, let's say 1, and then that's going to give me what I'm looking for. So I need to, if I want to index this, I have to do it in like 2 separate things. I have to first do, um, I have to first select the range in steps. That's the first side of it, the first thing that I have to do, and then I have to index it. Okay, hold on. I need to step away for a couple of minutes. I will be back soon. Voice crack again. What is going on? Yeah, I'll be back. I'll be back soon. Okay, I'm back. Sorry about that. Uh, where were we? I was looking into the sliding window thing, and more specifically, I was looking into this stepping syntax. I'm not sure what to call it. Hold on. Let me open up my chat on my phone again. Oh, back up. Close that, close that. Holy shit. I had one of Sayu VTuber's TikToks playing, and I don't know if there was any like music or anything in that, so I had to like scramble to close it. Uh, okay. Let's pause this and okay, we are good. Oh, you know what I should do in the future? I just realized that I panicked for nothing. I could have just reduced the volume of my phone because I anyways do that when I have my stream open on my phone so I can see my chat. I usually lower the volume of the phone and I also pause the stream because I mainly wanna see the chat. Actually, I'm curious about something. Okay, so we've got this, we've got this. Oh, yeah, okay. You know what? That's okay. Yeah, that's okay. Okay, so back to this. For the sake of having a simple example, we can do, I mean, we have a simple example already. We have a list of strings, and then we do things with the strings. Hold on. Let's comment all this out and come down here and C is that. Actually, no, we can do it here. I don't need to go down there. Okay, D equals. Oh yeah, we were trying to do the sliding window thing, and well, okay, not right now though. Right now we are trying to do this. So if we do it in this way and then print that out, what are we gonna be looking at? Yeah, I'm curious about that. Okay, so if we print it out like this, then we are looking at. Oh, yeah, okay. So, if I first do, so if I, let's say I put this into np dot array, let's say I put this entire thing into np dot array, and then we create a dwin, which is, um, was it d dot sliding window? No, it's np dot sliding window. No, it's not np dot sliding window either. Uh, is IntelliSense freaking out? Oh, it's just sliding window. Sliding window is its own function. Okay. Yeah, it's not from np. It is from np.lib.stride tricks. What else is there under stride tricks? It's not showing me anything. Oh, is it just this? It's just these two options that we have as strided and oh, can we specify? Oh, you know what? Wait, let's do that. Let's do that. So then it's just this, right? Wildcard import from a library not allowed. Why is that? Unable to hold on. Unable to detect undefined names. Okay, let's do it this way. So if we do, okay, what does as strided take? It takes an array like, it takes a shape, and it takes strides. How am I meant to use as strided? Let me, rather than looking at the documentation, I think I'll just ask Gemini. In Gemini, not in Gemini, in NumPy. In NumPy, what does as underscore strided do? In NumPy, as strided is a powerful and notoriously dangerous, okay, tool used to create a new view of an array. Wait, I'm curious about something else as well, because this was part of something tricks, right? Let's do from numpy.lib. What more do we have? We have array utils, format, introspect, mixins. Mixin classes for custom array types that don't inherit from, okay. Wait, am I able to scroll this? Never mind. NPy.io, rec functions, collections of utilities to manipulate structured arrays. Most of these functions were initially implemented by John Hunter for matplotlib. They have been rewritten and extended for convenience. SciMath, stride trick. Okay, okay, all right. Okay, yeah, back to this. Used to create a new view of an array by manually manipulating its shape and strides. Think of it as a way to trick NumPy into looking at the same memory buffer through a different lens. Without, that's why we specify the shape. We can get it. We can specify a different shape for the view. Yeah, we can specify a different shape for the view. Uh, Yeah, by manipulating its shape and strides. Think of it as a way to trick NumPy into looking at the same memory buffer through a different lens without actually copying any data. The core concept, strides. To understand the function, you first need to understand strides. A stride is a number of bytes you must step in memory to get to the next element. Yeah, that's a stride. Okay, good way to put it. To get to the next element along a specific axis. For example, in a 1D array of 64-bit integers, 8 bytes each. Oh, back up. Okay. Stride in this case is not the element count, it's the byte count. That makes a difference. That makes a huge difference. That is probably also why this is notoriously dangerous. Okay. If you tell NumPy the stride is 0, it'll keep reading the same memory address over and over again, effectively tiling the first element. How as strided works. The function signature is generally so-and-so, so-and-so. X is the source array. Shape is the desired dimensions of the new view, and strides, the custom byte steps for each dimension of the new view. Okay, you know what? Okay, wait. Common use cases are sliding windows, creating patches or windows over an image, or time series data for convolution-like operations without copying the data. Broadcasting, implementing manual broadcasting by setting a stride to 0. Efficiency, performing operations on overlapping segments of data with 0 memory overhead. Wait, I noticed you mentioned that stride here is byte count. I was assuming element count. Element count? Yeah, that's, I was about to say index, but no, element count. Because I have, there are other situations where I've seen stride being used as well. And to be fair, even in those situations, stride was being used specifically for byte related stuff, specifically to specify bytes, because in a lot of those cases where stride was being used, it had to do with bytes, like the operations being done there. It was revolving around bytes, so that's why there also you were using bytes. Okay, this is exactly where most people run into trouble. It's a very common and logical assumption, but in NumPy, strides are always measured in bytes. This is because NumPy sits directly on top of C, and different data types occupy different amounts of space in your computer's memory. So, I mean, this would probably then get complicated if you have an array of. Actually, no, would it? Yeah, yeah. I mean, yeah, this would get kind of complicated if you have like a list of dictionaries, and the dictionaries each have two keys, and each of those keys have string values, which could be of any length. The thing is, the strings are not being stored in that exact location. If it's a string, I'm pretty sure it's a pointer, and so the pointer is going to have a fixed size. So then we just need to know the size of the pointer and the size of the dictionary in total, and then we'll know, um, is there a size function in from NumPy import size? Now that's NumPy. From NumPy core, okay. From torch, yeah, none of this is in Python's standard library. Okay, strides are always measured in bytes. Okay, okay, okay. Why bytes matter? If strides were measured in elements, NumPy would have to do extra math behind the scenes every time you accessed an array. By using bytes, the CPU can jump directly to the memory address. That's true. That is true. If you are doing the calculation manually, then the CPU doesn't have to do that calculation. And if you specify the exact offsets that it has to use, it doesn't have to calculate those offsets by itself. Okay, calculating the stride to make your code portable and safe, you should rarely hard code numbers like 8 or 4. Instead, you use the item size attribute of the array. Okay. If you have a 2D array and want to move to the next row, the stride is number of columns multiplied by item size. All right, let's take a look at item size here. So let's do C dot item, is it? No, it's D. D dot item size. $152. That's crazy. Oh, it's worth noting that here it's a list of what do you call it? It's a list of strings. This isn't even a dictionary. This is a list of strings. Okay, what if I have a NumPy array, an ND array, containing a list of, well, the array itself is a list containing dicts where dicts that have two keys each, and the values of those keys are str. This is where things get interesting and a little bit weird, When you store objects like dictionaries in a NumPy array, the array is given the dtype object. In an object array, NumPy doesn't store the actual dictionary. Data inside the array's memory block. What? Doesn't store the actual dictionary data. Okay, the actual dictionary data inside the array's memory block. Instead, it stores pointers. All right. So the dict is also a pointer. Um, Wait, is the dict also a pointer? Because like, okay, the strings are pointers. Is the dict also then a pointer that points to those? Oh, okay, yeah, yeah. It stores pointers that point to those dictionaries, point to where those dictionaries live um, in your system's RAM. How stride works with objects. Because NumPy is just storing pointers, the size of each element is the size of a memory address. On a 64-bit system, it would, okay, so that's what I thought. It's the size of the pointer. Okay. So even though your dictionaries might contain long strings or many keys, the stride of the array will almost always be 8 on modern machines. Why as strided is extra tricky here. When you use as strided on an object array, you are manipulating pointers, not the dictionaries themselves. Okay. Memory size is constant. Whether the dictionary has 2 keys or 2000 keys, the item size remains 8 bytes because the pointer size doesn't change. Is item size the size of one item or what? Okay, it doesn't mention that here. Um, hey, so I have a list. I have an ND array of str. Help me understand why item size is 152. Is that what it said? 152? Yeah. That is a massive jump from 8 bytes. The reason you're seeing 152 is that you aren't seeing an object array. You are using a fixed width string array. In NumPy, when you create an array of strings without specifying dtype object, NumPy calculates the length of the longest string and creates a fixed size bucket for every single element to ensure the memory is contiguous and fast. The math behind 152. Okay. NumPy uses UTF-32 encoding. UTF-32. All right. For its Unicode string arrays. This means every single character takes up exactly 4 bytes. If your item size is 152, we can reverse engineer the bucket size NumPy created for you. That's interesting. That's interesting. Hold on. I want to see how true this is. Hold on. I'm pretty sure it's accurate, but yeah, I just want to see. Up to so 152 is the longest. What's a quick way to get the longest string? I mean, I could just write something here, right? Longest str equals so and so for I in. Now I'm curious because I'm sure NumPy probably has. Okay, in NumPy I have an array of strings. How do I find the longest string? I was about to write like a simple for loop to iterate over the entire thing. Finding finding the longest string in a NumPy array is a bit different than standard Python lists because NumPy handles strings as fixed width. Then let's change that. In Python, I have a list of strings. Using max. Oh, that's interesting. There's a max function in which you can provide a key to do stuff. Wait, that's crazy. Hold on, we are learning stuff. I don't think I've ever used this before. Key len. Let's see what. Okay, this doesn't give an explanation. That's okay. Wait, what more does this function have? Okay, it doesn't give any information there. Let's print out longest str. That's crazy, dude. That's crazy. Okay, so we get longest str. This is telling me that I should take a look at those built-in functions because Python's standard library has a list of built-in. This is part of the standard, yeah. Python's standard library has a list of built-in functions. And this is something I had no idea that I could do. Okay, so what was I trying to do here? I was trying to get the length. The length of the longest thing is 38. Okay, so we're gonna do something here. Okay. We're gonna try to get to 152. Okay, we know the length of the longest string. And you know what? Okay, we'll just do byte count or char count. Char count equals 0. For I in C, char count equals char count plus len longest str minus len I. Oh, empty char count. And then full char count. What should I don't know, let's just say char count. Char count. Okay, so then this would be empty underscore char count, and this would be char underscore count. Oh, wait. Yeah. I'm sure there's probably a better way to go about doing this, but for now, this is working, so I'm just going to go with this. This is something that I've learned is that do what works in the moment. Don't worry about optimization until you actually need the optimization. So char count plus, in this case, we just want to do len. Yeah, len I. So we just want to count the, yeah. Okay. So print f char count is char count, and then empty char count is empty char count. And then total is char count plus empty char count. Three 304. That's interesting. Oh, wait. Um, no, hold up. I think char count and empty char count also need to be, I think they also need to be multiplied by 4, right? So empty char count equals empty char count. Does Python have this? Because I believe Rust doesn't have it, but I think Python has it. Yeah, Python does. Char count. No, that made it way too big. Okay. What am I missing here? So we are getting the length. We're getting the char count. I should then do byte count. I mean, that's still just a name. Should we do the multiplication first? I mean, we are getting the number of chars first, right? And then we are multiplying that by 4 in order to get the number of bytes. And if that is the case, now that's confusing. Hold on. So the length of the longest string multiplied by the length of the current string is added to the current empty char count. Wait, let's do E, and here we can do ABC, A B C D E, and then A B C D E F G. Wait, that hold on, that's interesting. What is longest str coming up to? 38. If longest st, oh, okay, change this in E, and then, so the longest thing is 7 characters long. This is so silly. I'm wasting time on this, but anyways, okay, the longest thing is 7 characters long. Okay, empty character count is 24. That doesn't make sense because what I'm trying to get here is not empty. Like if we do, okay, FG 1, 2, 3, 4, 5, 6. That should be our empty char count. It shouldn't be what's showing up there. So what's the issue here? The longest string, is it getting it right? 7. Yes. For I in E, empty char count equals empty char count, which is 0 initially, plus the length of the longest string minus the length of I. Let's print these out as well. Let's do empty char count and char count. Let's, wait, what is, so initially it's counting empty char count as 4. That's weird. If the longest string is, you know what, that's not weird. No, empty char count is 4 there. Yeah, no, that's my bad. The empty char count is not, it's not wrong there. So 4 and 3. 4 and 3. Okay. In the next iteration, which is here, our empty char count should be 2. And then 2 plus 4 is 6. Okay. Okay. So that's adding up there. And 3 plus 5 is 8. So we get 6 and 8. And then in the next one, empty char count is 0. So as in there's no empty characters there. So we get, it remains 6. And the char count there increases. I think that was the problem. The char count there is increasing. How should I handle this? Because we're going to have, so we have char count plus len I, okay. Actually, yeah, then in total, it should, so this should be accurate, right? What did this give us? 84 seems like a lot. It doesn't seem accurate. And also, the char count became 60. How did that happen? Oh God, this is why. Now it's accurate. That's crazy. So was it 6 characters? It was 2 and 4, 6. Yeah. Okay. And then there was 21. There was 15. There was 15 characters and there was 6 empty characters, and that became 21 characters in total. And if we multiply this by 4 each, then we get 84. Okay. So then let's do this and get rid of this and also this. So then this might actually be accurate. What is the longest string here? So the first thing that's being printed, I think the longest string is 38 characters. Yeah, I think so. I think the longest string is 38 characters. So then we are subtracting each of them from this. And first we are getting empty char count, which is 14. And then we get the char count, which is 24. Is that, like, I'm trying to get this math right. Because this is already saying 304. Oh, hold on. What if I multiply this by 4? That's so fucking stupid, dude. It's because of my stupidity. But yeah, 152 is correct. Yes. 152, it's down here. This. So, yeah, that was correct. Anyways, let's get rid of all of this. Um yeah. Okay. What was I where was I with this? Okay, why is it so big? That's what she said. But why is it so big? Unlike Python lists, where strings can be any length because they are stored elsewhere, NumPy wants to be able to calculate exactly where any element is using a simple formula. Address equals start plus index multiplied by stride. And the only way they can have the stride, okay, so the only way they can have the stride is if they have like a fixed value, and the way that they set the fixed value is by finding the longest string in that list in the array and setting the size for every other array element to be that long. Now, would this be wasteful? Yeah, I'd imagine so. It would be wasteful if you are dealing with strings specifically, but I wonder if um, this would be wasteful in terms of RAM, but I think it would help the speed um, because of the determinism in it, like because of how deterministic it would be. Um, how do I say that? Deterministic in the sense because it knows where exactly it needs to jump. It doesn't need to calculate. It doesn't need to like go fetch where a pointer is pointing. It knows like exactly where it's supposed to jump, and because there's that deterministic behavior, so it's able to do calculations in a lot more optimized way. Okay, to make this math work, every slot must be identical in size. Yep. Okay. If your longest string is 38 characters, every slot must be 38 characters. How this affects as strided. If you use as strided on this array, your stride one element over for moving one element over would be 152. If you mistakenly use a stride of 8, thinking they were pointers, you would end up reading the middle of a string's memory, resulting in a mess of gibberish characters. Now, I'm going to ask this thing that I was mentioning before, I'm going to ask a question about it. Um, okay, so using the size of the longest element does seem like it would make things a bit more deterministic and allow um, for more optimized code to be written for operating on such data. But I'm wondering, wouldn't this also be a bit wasteful? You've hit on the classic space versus speed trade-off in computer science. You're absolutely right. It is incredibly wasteful in terms of RAM, but it's highly optimized. Okay, that's what I was thinking about. But it is highly optimized for the CPU. In NumPy, this is called internal fragmentation because every slot must accommodate the largest possible resident. You end up with a lot of empty bytes null terminators if your strings vary in length. The cost of predictability. If you have 1,000 strings where 999 are just one character long, but one string is 38 characters or 152 bytes, NumPy will allocate 152,000 bytes, which is 1,000 multiplied by 152. Um, Wait, that's crazy. 152 KB for that. If you had used a standard Python list of strings, it would only take up about 50,000 bytes. Okay, that's not all that different. That's just 100 KB less. I was expecting it to be a lot lesser, or rather, I should say, that's not a lot more. As in, 152 KB is not a lot more than 50 KB. So it doesn't seem that wasteful. But like, I'd imagine if you, because this is a simple example, right? If you scale up this wastefulness, it could become a lot of wastefulness. But I guess that's the price of doing optimized calculations. Yeah, yeah. Why NumPy accepts this waste? NumPy is designed for vectorization. Here's why the waste is often considered a fair price. Direct memory access, as we discussed with as strided, if the CPU knows where every element is exactly, if the CPU knows every element is exactly 152 bytes apart, it can jump to the 500th element instantly. In a list of varying lengths, the CPU would have to crawl through all previous elements to find where the 500th one starts. Cache friendliness. Contiguous memory blocks, even with empty space, contiguous memory blocks, even with empty space, are easier for for the CPU to load into its high-speed cache. Jumping around jumping around to random memory addresses like an object array does causes cache misses, which are much slower. I keep forgetting about like the cache prefetch thing. I feel like I should remember the cache prefetch thing a lot more often. If I'm being honest though, with something like Python, I rarely ever think about cache prefetch. Um, though in this case, I think it's not happening on the Python side, it's happening on the C level. Because like whatever is being prepared on the Python side, it's being done so that operations can be done more um, optimally in a more optimized manner on on the C level. Okay, the next thing is SIMD, single instruction multiple data. Modern CPUs can perform operations on. Dude, it was really interesting learning about how SIMD operations work. And we learned about this in one of the previous streams where we were looking into how SIMD operations are performed in the CPU. And it turns out what happens is you have like a wide register that's created for the SIMD operation, and you would bundle up the entire data into that register so that that one instruction can do the operations on all of those pieces of data. And then that gets returned, and that's basically your vectorized operation. The entire operation has been done on like a batch of data because the register is just that wide that it allows multiple pieces of data to fit in so that the instruction can then be performed on all of those pieces of data. And that's really useful because this way you can vectorize operations. You can perform the same instruction on multiple pieces of data, thereby saving CPU cycles. Though I guess it would depend on like how fast the CPU is able to do that, but I'd imagine it being able to do the operations within the same register, it kind of speeds things up a lot more. And or rather, I should say, Well, and or and there's also the fact that it's possible that doing doing the operations in this vectorized manner, while it may involve a couple of CPU cycles, the amount of cycles involved or the amount of CPU time that gets used up in doing this vectorized operation would still be much lesser than if you were doing the operation on those individual pieces of data. Because anytime you're doing such operations, the data has to be loaded first. It has to be loaded onto, and the only reason I know about this is because I've done assembly in the past. Like, dude, I don't use assembly at all. Like, at all. It, in terms of usefulness, it is not something that I've used at all practically for anything. Ever since I learned it. I did a couple of like fun little toy projects with it. Like I wrote a file encryptor, well, file encryptor and decryptor in assembly. And I created my own like algorithm for encryption and decryption. And I think I worked on one more project, and other than that, I also worked on like 16-bit assembly projects, like tiny 16-bit assembly projects, bootloader programs. Yeah, they were bootloader programs, the 16-bit ones. But yeah, I learned this language solely because I wanted to understand how programs work, how programs are executed. I didn't learn this language. I didn't learn assembly so that I could hand code assembly programs, but learning assembly taught me so much more than just assembly. Learning assembly is the reason why I understand what it means for a value to be X number of bits. And learning assembly is also why I understand how program execution works, what a function stack frame is, um, stuff like prologue, epilogue. Oh God, OBS froze. Hold on. Wait, I hope it's not about to crash. Speaking of crashing, I still need to stitch one of those previous streams that where OBS crashed. Oh God, dude. Are we still good? Uh, okay, okay. We are freezing again. Um, hold on. Hold on. I'm just giving it some time. Okay, I think we're good. Yeah, so anyways. Oh, wait, just a minute. Okay, yeah, we are good. So, yeah, dude, learning assembly, it taught me so much more than just assembly. Like because of learning assembly, I was able to explore a lot of other OS level concepts, stuff like, you know, file formats. Um, like that's when I truly understood the meaning of a file format. And that's when it really clicked for me that when we look at files, any given file on your system is just a collection of bytes, right? Literally any file on your system is just a collection of bytes. Programs that read these files, they interpret those bytes to do something with them. Your OS would load an exe file. Even that has a file format. So if it's an exe, it's a portable executable, PE, which is used on Windows. On Linux, you have, I think, one or two different formats, but a very common format is ELF, ELF binary format. I'm guessing, Mac OS has their own format, but that's all executable stuff, right? Then you have like images, you have media formats, you have images, you have videos, you have audio, then you have even like text format, and even like you look at images as well. They When you look at the file format of that, there's usually headers at the beginning. The raw data for this for the media file, it doesn't just start at the beginning. The beginning of the file usually has something called a file header, and that header contains a bunch of different fields with a lot of different types of information. That information is used by the program that loads the file. So you don't necessarily need to know anything about it in order to do something with the data, but the program needs to read that information in order to know what exactly it has to do. These file headers, they allow us to have very complex behavior within these file formats. It's really interesting. Like, dude, it is, yo, the amount of things that I learned when I was exploring assembly. I learned more than just assembly when I was learning assembly. It is insane. I'm so glad that I actually took the time to learn assembly and um, learn how to use debuggers to step through, because that's the best way that you can actually learn assembly, is that you do the assembly coding, and then you run your program through some kind of debugger or disassembler or something. In this day and age, I don't I don't think you should limit yourself to something like what was it called, GDB, I think. I don't think you should limit yourself to the, I think it's called the GNU debugger. Yeah, that's right, GDB. If you're on Linux, you probably have GDB like by default, but I don't think you should just limit yourself to that. Use the more advanced and sophisticated debuggers and disassemblers that we have today. My Something that I've used in the past, two of them actually. There's Radari and there's Cutter. At this point in time, they're both different projects. They're not the same at all. Radari has its own. So Radari started out as the, let's call it the TUI, though it's like a mix of TUI and CLI. It started out as a terminal based. That's the best way to put it. Terminal based application for doing debugging, disassembling, and a lot more. Not just debugging and disassembling. There's so much more that you can do with it. And they built Cutter as a GUI front end for Radari. Initially, that's what it was, and then I think at one point in time they kind of split the development. I don't remember the exact history, but like this is just what I remember. I think they had split the development of Radari and Cutter, and they were still like within the same team. But then sometime later, Cutter like split out on their own, and now Cutter is doing its own thing. They have a separate backend. They don't use the Radari backend. We froze again, so I'm gonna stop talking until we unfreeze. Okay, okay. I think we unfroze and we should be good now. Yeah. So sometime later, Cutter they split up. They split away, split out, split off. They separated from Radari to do their own thing. And since then, Cutter, my understanding is Cutter is using a separate backend. They developed their own backend, or maybe um, they started using another backend that was in development. I don't remember if they developed the backend or there was already another backend in development that they decided to build on top of. You're gonna have to look that up yourself. But yeah, now Cutter is using a separate backend, and Radari, they have built a new GUI front end. I forgot what that is called as well. Either way, the point is they're both great. You can use whichever you want. It's just that due to their differences, they decided to split up and they're doing their own things. But I'm sure they both like support each other. Um, I don't think one is better than the other, especially if you're like a beginner in disassembly and learning assembly in general. If you're a beginner in all of this, just pick one. Cutter is like super easy to install. I'll tell you that. That being said, it's not like Radari is super complicated to install, but like I'm just saying, I've used Cutter, and Cutter is super easy to install. Um, yeah, dude, learn this stuff. It is incredibly useful. It is incredibly helpful because there's been so many bits of knowledge that I gained from learning assembly. I keep repeating this, but like there's been so many bits of knowledge that I've gained from learning assembly, that have helped me in many different places. Like when I was learning assembly, I learned a lot more than just assembly. And whatever I learned, other than just assembly, it has helped me out immensely in a lot of different like coding related things, and even just in general trying to understand how various things work. It has been incredibly helpful for me. Okay, so we're gonna continue with this, but give me a second. Okay, cool. Now, um, where was I? We were doing the Python slicing thing. Every third element starting at index. Oh, okay. This is wait. Yeah, this makes it interesting. So, D slice, I think, sliced. Oh, we are not doing the yeah, wait, no, we still have to. What was I gonna do here? This. Okay, and then we print out D. Um, that's D. And okay, so and this is like Python basics, right? But I don't use this feature nearly as much as I should, which is why I just don't remember too much about it. But generally, the way that it works is you have start, end, or start, stop, I think, end, stop, whatever, and then step. So you can specify where it should start and you can specify where it should end, and then starting at the start point. Oh, accidentally hit a key on my other keyboard. But yeah, then starting at that start point, it's going to read and then step um, with the number of steps, and it's going to keep doing this until it hits end. So what I could do here is, for example, I could say start at, we have, okay, let's start at index 4, which would be O3. And if I'm getting this right, it should skip 2. Does that mean step over 2 or does that mean step to 2? So does it mean that it's going to read O3 and then jump to O6, or is it jumping to O5? It jumped to O6, so it steps over 2. All right, now I'm getting it. Dude, 10 plus years doing Python, and I haven't used this feature nearly as much as I should have. So now I'm sort of relearning it. I'm pretty sure I learned this at the beginning when I was learning Python, which again, decade, decade ago. Um, and now I'm relearning this. Holy shit. Now, what was I trying to do? Where was I going with this? So we were going to have a sliding window, and then I wanted to control the steps that the sliding window takes. Because the sliding window by default, it jumps every element. It doesn't skip any elements. You get to specify the window size. So, okay, we're going to do. Oh, you know what I could do? I could probably, um, I could, well, no, that's not going to be accurate. Yeah, that's not. I was about to pass in like this kind of, um, what do you even call this kind of a list? Hold on. Okay, another thing that this thing is specifying is enumerate, but that's more for loops. However, there's a catch. Enumerate starts its counter at 0 by default. If you slice a list, the index it gives you is the index of the new smaller list, not the original one. Okay, yeah, that's enumerate. We'll look into enumerate later on. Pro tip, the reverse slice. One of the coolest uses of the step value is using -1. It tells Python to walk backwards. So-and-so will give you the entire list in reverse. I should keep that in mind. I believe there's also a reverse function, isn't there? There was like a reverse function, I think. Hold on. There's reversed, which is a class. Let's, I don't know, let's do reversed D. That, wait, this is when you call it as a function, it gives you an iterator. So we would need to iterate over this. What if I just printed the thing out? What happens then? That's an iterator. Okay, we need to make a list out of the iterator. I'm glad that I've explored this stuff. And the only reason I've explored these, dude, this is interesting. Like when you're learning Python, definitely go through the built-in functions list because there's a bunch of things that you can do. It's a bit of a long list, but like exploring that list is definitely going to help you. Um, I mean, if I'm being honest, then like at this point, if I were learning Python newly and someone told me to read that list of functions and like look into what every single function does, I probably wouldn't do it. Um, like each of these things that I've learned, it's been like based on, the need for it, the use for it. Like for example, okay, so here we are able to pass in what does wait, list is also, yeah, so list takes an iterable, and we know that reversed gives you an iterable when you are calling it as a, how do I see the, yeah, there. It gives you an, well, it gives you an iterator, which is iterable. So, yeah, then we can convert this to a list and then it's going to print it out. And this is in reverse. Right. So, oh, yeah, I was going to ask this question. Hey, so, vocab wise, if I have a list, A equals 0, 1, 2, 3, and I do A, so and so, so and so, so and so, what kind of list would I say I'm receiving? In Python terminology, what you're receiving is a shallow copy of the original list, specifically created via a stride. While most people just call it a slice, here's the specific vocabulary used to describe that result. The result, a shallow copy. When you slice, okay, so this is a slice then. What I'm getting is a slice. Though, no, hold on. Okay, let's read this. When you slice a list in Python, you aren't just looking at the old list, you are creating a new list. It is shallow because if the list contained objects like other lists, the new list would still point to those same objects. Changes to the structure of the new list, like adding an element, won't affect the original. The technique, striding. Okay, the so and so part is technically called the stride or the step. If someone asks you what you're doing, you'd say, I'm slicing the list with a stride of 2. Okay. This tells Python to jump over, um, over a certain number of items instead of taking them contiguously. Terminology: slice, the general operation of selecting a range of elements. Stride step, extended slicing, subsequence. Wait, a quick heads up. In the standard Python lists, slicing always creates a copy. However, if you ever move into NumPy for data science, slicing creates a view, meaning if you change the slice, the original data actually changes. Okay, would it be accurate to say, or to call the returned list a slice? Yes, it is completely accurate to call the returned list a slice. In the Python community, slice is used both as a verb, which is the act of cutting the list, and a noun, the resulting object. While stride describes the method of skipping items, the output itself is still a slice. You know what? Okay, that's good enough for me. And we have learned this now. So what was I gonna do? Oh, yeah. So the reason I was trying to learn the slicing thing, now I guess we can go back to this. Okay, get rid of that, uncomment this. We want to go over this. How many do I want in this? So we're going to take 10 dialogues, okay? With a window size of 3, we're gonna take 10 dialogues, and then we're gonna have a stride of 2 while stepping over this. No, no, hold on. How do I want? So, okay, we have the, what am I trying to do here? Okay, okay. Sliding creates a sliding kind of thing, but it slides over each element, right? Great. So now we have a bunch of views in this thing within this, but this is an ND array. Okay, I need to ask Gemini a question. I was about to say, okay, we have now 10 separate views, right? It's an iterator. We can iterate over it, and it's returning a view into each of those windows, right? Each window is sliding by one element. So if because each window is sliding by one element, if we create a step of 2, we then get to skip over 2 elements. Yes, we get to step over 2 elements. So if I'm calculating this right, with a window size of 3, oh, with a window size of 3, um, if we skip 2 elements, we shouldn't be seeing any repetition at all, right? Let me just okay, let's get rid of this. Get rid of this. Let's say sliced. And then we wanna iterate over the sliced version, and we don't need this anymore. So we should not be seeing any repetition. Let's confirm that. We are seeing repetition though. That's interesting. That's interesting. Because like what's happening here is like if we, okay, let's come up here. Okay, so we have one window here. Notice the last item in this window. Um, the next item starts with that. And then notice the last item in this window. The next window starts with that. So what am I missing here? Wait, I need to... Hold on. Okay, so I have... Wait, okay, so let's go back to... Wait, no. Was there a different easy way of slicing each view? Sliding window view. Okay, okay. So another thing I'm going to need to consider here is that I'm not trying to do the slicing window thing based on the index itself. I'm more trying to do the sliding window thing based on time. So it's supposed to be like, okay, we read from 0 to, as in 0 seconds, to the closest thing to 30, the closest end, the closest ending timestamp to 30. In this case, the closest ending timestamp to 30 is 36, right? Anywhere else in the list, it's not, there's nothing that's closer to 30. Oh, I should also add closer, equal or greater than, because if I do equal or less than, then the closest one would be 25. But yeah, the closest to 30 is this, right? So this is one window. I want the next window to start. Actually, no, I said that wrong. It's supposed to be between, the window is supposed to be between 0 and 60 seconds. So the window is supposed to be 1 minute long. And then the next window should start at 30 seconds after the first window. Yeah, yeah. The next window should start at 30 seconds after the first window. I feel like I'm going to have to construct the windows myself in this case, because here it's not sliding windows by, here it's not sliding windows by, what do you call it? Here it's not sliding windows by index. It's sliding windows by the time that is within each of these dictionaries. Um, okay, hold on. Let me open up a new Gemini instance. Hey, so I have, um, I have, I have a VOD transcript, which contains timestamps. It is a list of dicts, um, where each dict has two keys, a timestamp key whose value is a list of floats, whose value is a list of two floats, start and end, and a text key whose value is a string, is a str, the dialogue being said. I want to create a sliding windows that slide over this entire list. However, the stride must be, the stride, I'm going to put that in brackets or in quotes. The stride must be um, the stride must be, oh, 30 seconds in the start time. So, okay, I think we have a problem here because this makes things not so deterministic. Yeah, this is not going to be deterministic because the window size is variable. It's not fixed. It's not constant here. We cannot guarantee that every single dict within or every single window is going to have the same number of dicts. I should say dictionary because each time I say dict, it sounds like I'm saying dick, and then it sounds like I'm saying dicks, and like dictionary. So I forgot what I was saying. What was I saying? Yeah, the windows are not going to be same size. Right. So let me also mention that here. I feel like I can't use NumPy's um, sliding window here because um, the windows are not going to be, or the windows, yeah, the windows are not going to be fixed length. Okay, this is a classic data processing hurdle. You're spot on about NumPy since your window is defined by the time duration rather than a fixed number of. I feel like if I put this into pandas, I would probably have an easier time doing the processing because I would be able to write some sort of filter, some sort of function. I'll have to revisit that whole thing again because pandas does have its own way of um, Pandas provides you with a way to run a sort of filter over your entire data frame, and you can like write a program to, filter out a bunch of, you can write a function to filter out a bunch of data from it and return, very specific data, like data based on certain criteria. And you can get fairly complex with the kinds of functions that you can write there. Okay. Um, Yeah, since your window is defined by time duration rather than a fixed number of elements, standard array slicing won't cut it. Because one 30-second block might contain 10 short lines of dialogue while another contains only two, you need a dynamic approach. The most efficient way to handle this in Python is using a two-pointer or sliding window approach. We are talking about sliding windows right now. What do you mean two-pointer or sliding window approach? Okay. The logic. Iterate by time, move your start time forward by 30 seconds each step. Find the range. For each start time, find all dictionaries in your list where the dialog falls within start, start plus window size. Efficiency tip. Since transcripts are naturally sorted by time, you don't need to rescan the whole list every time. You just need to find indices that fit the current time bucket. Python implementation. Okay. Um, hey, I'm wondering if I would have a better time um, if I converted, or well, I'm wondering if I would be able to do something um, with pandas here. You definitely can. While pandas is usually associated with fixed row operations, it's actually quite powerful for this because of its ability to handle interval arithmetic. Using pandas makes the process more declarative. Instead of writing a manual loop to filter the data, you can leverage a pd.interval index or a simple apply logic. The pandas approach, the most readable way to do this in pandas is to define your window boundaries first and then join or map your transcript rows into those buckets. Okay, okay, okay. And then for so and so, window data dot append. Why use pandas for this? Vectorized text processing. Once you have the window DF, you can run sentiment analysis, keyword extraction, or token counting across the entire text combined column instantly. True. That is true. Actually, yeah, that is true. So if I converted the entire thing into if I converted the entire thing into a data frame, I would probably have an easier time processing the thing because there's a lot of filtering that I have to do, and there's also simpler operations which they wouldn't have been all that harder with Python's standard library approach, but it might be easier and perhaps maybe even faster if I'm doing it using pandas. One example is like, I guess, joining up the entire, like an entire string column. Another example, I guess, would be, and that's probably what's being covered here, is we have like a list of values. I could run a filter over the entire thing. Oh, yeah, I forgot what the function was called. Maybe it's apply, maybe apply. I think it applies something to all of the things, um, all of the rows in the data frame. I think apply does that. There's something else that I need to look for. I forgot what the function is called. I'm pretty sure I'll find it eventually. But there is a function in which you can maybe it's map. Maybe it's just called map. Um, hold on. Um, do I have pandas here? Um, import. I do not have pandas. I need to install pandas. That's fine. I can install pandas here and then reopen this. I could install pandas right now. I could install pandas right now. Hold on. Do I have it here? Yes. uv pip install pandas. That is wrong. Don't do that. Pandas. Okay, pandas is installed. So we're going to close this now and reopen and select VOD splitter, and there's our session. Awesome. So now in here, I can add pandas as PD, and down here, let's create df01 equals pd dot data frame. we have to pass in, okay, so let's say 0, 1, 2, 3, 4, and then B would be also, no, let's make it different, 5, 6, 7, 8, 9, and then C would be A, B, C, D, E. That's 5, right? Hold on. That's wrong. That's right. Okay. So, now df dot, is there a map? There is map. Apply a function to a data frame element-wise. This method applies a function that accepts and returns a scalar to every element of the data frame. Okay, then what is mask? Replaces values where the condition is true. I should keep this in mind. Okay, then we also had, is there filter? Subset. That's what I'm looking for. Subset the data frame or series according to the specified index. That is probably not what I'm looking for. No. I'm looking for, this applies a function that accepts and returns a scalar. Python function returns a single value from a single value. What was it? Is there apply? Apply a function along an axis of the data frame. Objects passed to the function are series objects whose index is either the data frame's index or the data frame's column or the data frame's columns. By default, the final return type is inferred from the return type of the applied function. I'll have to wait. Okay, let me open up a new Gemini conversation again. I'm going to have to remember to close a bunch of these after the stream because I'm going to end up with clutter. In pandas, what options do I have in terms of applying a function to an entire data frame? More specifically, if I wanted to filter a data frame, what are the options? Actually, give me all the options because there might be other stuff that I want to, like maybe returning windows of a data frame based on certain conditions. Pandas is essentially a Swiss Army knife for data manipulation, and there are several ways to apply functions depending on whether you want to transform values, reduce data, or filter rows. Fortunately, in this case, it's all I want to do is filter rows. Okay, so there's apply, apply map, pipe, chaining multiple custom functions. I didn't know that was a thing. Transform, returning a result with the same shape as the input. Apply map, apply a function to every single cell. Now it's called map. Okay. Oh, now apply is called map. Filtering options. Oh, dude, I didn't think about that. Holy shit, I didn't think about that. There's like the very simple indexing approach where we do something like this, df a less than or greater than 0 and df a. I think I should do it like this. Less than 4. So this should give us 1, 2, and 3. Right? Let's print that out. Let's see what this returns. Oh, it's supposed to be df01. We still have an issue because now it's a Boolean operation. The truth value of a series is ambiguous. The truth value of a series is ambiguous. Um, well, okay. Anyways, we can use Boolean indexing to select rows based on certain conditions. We can use Boolean indexing to like filter essentially. I completely forgot about that because if we are separating the start and end time into separate columns, then it would be like super easy for me to just select, you know, all of the rows that are within a certain thing, and then I can create like a list of windows and just pass that list of windows into whatever model I'm looking to use. But okay, holy shit, we've been streaming for 2 hours and 10 minutes. We went longer than I thought we would, which is pretty awesome. Uh, uh, okay, so give me a second here. You know what? I don't think I'll wait, learning 3D for web dev. Interesting. Now, you know what? I don't think I'll raid anyone today. I'll just continue with this because I usually like to stick around after I raid just to, you know, chat with the person a bit and, you know, do stuff. Actually, okay, if that's the case, because nah, okay, yeah, we're just gonna end. That's gonna be it for today's stream. And yeah, dude, we're gonna stream again tomorrow. We've got a pretty good stream streak going at this point. We've been streaming for more than a month, consistently. I'm pretty happy about that. I'm super happy about that. We're also making good progress here with the whole, you know, content pipeline. Once I've nailed down once I've nailed this logic of sliding windows, then we're going to start processing the transcripts that we have created. We're going to run them through NLP models and see what kind of results we get. Okay, so that's going to be it for today's